Okay, so the following problem says that a force of 40 newtons accelerates a 5 kilogram block at 6 meters per second along a horizontal surface. So the question is how large is the frictional force and what is the coefficient of friction? So let's take these one step at a time, and let's go ahead and start with A. And using your 6-step problem solving method, I'm sure that's where you probably started. Let's go ahead and start with the block that we're working with. And the forces, I'm hoping you're saying, okay, so we should be drawing equal and opposite forces in the y direction because the box is sitting on the surface, it's not levitating. So we have normal and gravity. And then here's the part that's a little tricky on this one. It says a force of 40 newtons accelerates a 5 kilogram block at 6 meters per second squared. So the question is this 40 newtons the net or the applied force? And here's the deal. We're going to try to find a frictional force, and so this is going to have to be an applied force. So we have this applied force, and I'll talk more in a minute about why that has to be applied, and then this is going to be our frictional force. Now the question is, you can probably see I'm drawing the frictional force smaller than the applied, so what I'm wondering is why. Hopefully at this point you're saying you're doing that because if there is a net acceleration, that means applied's got to be greater than friction. So let's write down what we know. We know our F net in the x direction is equal to the applied plus the friction, and we know the F net in the y direction is equal to gravity plus normal. And remember, when we say F sub n, we can also just write that as n for normal. So we have our two F net equations, and you're probably saying, wait a minute, those equal 0. That's correct. In the y direction, gravity and normal are going to equal 0 because their forces are balanced. So it's going to keep doing what it's doing, and in this case that's resting on a specific surface. So we have the F nets in both directions. Things were given in the problem. We're given the information that the applied force is 40 newtons. We're given information that the mass is 5 kilograms. And we're given information that the acceleration is 6 meters per second squared. Now, we know a couple of different equations. We know F net equals ma net. We also know the force of kinetic friction is equal to mu sub k times the normal force. And let's go back up here and look at what we're trying to find. We're trying to find the frictional force. So what we really want to know is what does F sub k equal. So let's look at what we have. We have that there are 40 newtons in the positive direction, that's applied force. We don't know the net force, and we don't know the force of kinetic friction. But one of those two we have enough information to find, and in this case we have enough information to find the net force. This 6 meters per second squared is the net acceleration. So remember, it's the acceleration when you take the sum of the forces, the applied and friction, and then divide back out the mass. So we have a mass and we have an acceleration, so we can actually find F net. We don't have it yet, but we can find it by taking mass, which we're getting from this equation. Mass is 5 kilograms, and we know net acceleration was the 6 meters per second squared. So you should be saying, oh, well, your F net then is going to be 30 newtons. And 30 newtons, I'm hoping you're saying 30 newtons in the positive direction. We have a positive number here because we had a positive acceleration, so 30 newtons. And again, maybe we should clarify that that's in the x direction. So now that we have what the F net is, and we have the F applied, we can solve to get the force of friction. So I'm going to take this equation, and I'm going to rewrite it here. I should rewrite it below a little bit so I have a little more space. So F net is equal to F applied plus the force of friction, and I'm trying to find the force of friction. This is what I'm trying to find. So I'm going to subtract out the applied force on both sides. So F net minus F applied equals force of friction and kinetic friction, right? So F net in the x minus applied equals force of kinetic friction. And the net is 30 newtons. The applied is 40 newtons. So the force of kinetic friction is negative 10 newtons. Now let's take a minute and look at the problem. So what that's telling us is that if we have an applied force of 40 newtons, there's a kinetic friction force. This says negative, which is good. It corresponds to my coordinate system for kinetic friction because I'm pointing to the left or in the negative direction. So my kinetic friction then is negative 10 newtons. So that tells me that if I combine 40 plus negative 10, I get a net force of 30 newtons, which is exactly right. So my answer for A is that the frictional force is a 10 Newton force. Now here's what I want you to think about. At the beginning, I think some of you probably were saying, how do I know that this is an applied force? If this wouldn't have been an applied force, if this would have been my net force, it wouldn't have made a lot of sense, because if it's accelerating at 6 meters per second, we should be able to take, and has a mass of 5, 40 divided by 5 should have given us 8, but it didn't. So what you have to think about, this is one, I don't think it's as explicit as it could be, but this 40 Newton force has to be an applied force. Otherwise you don't have enough information to actually solve the problem. So that's only A. B then says, okay, knowing that all that's true, what's your coefficient of friction? So now what we are going to have to do is we're going to have to think about this for just a second, and we're probably going to have to, I'm going to have to make a little bit more space here on the problem itself. That F sub k was negative 10 newtons. So our frictional force was negative 10 newtons. So now we're being asked to find the coefficient of friction. And we have actually already a lot of the pieces of information that we need. So we're trying to find, in this case, mu sub k. And let's go ahead and clarify down here that now we've found that F sub k, again, was the negative 10 newtons. So if we're trying to find mu sub k, we have this equation over here, the coefficient of friction equation and the kinetic friction equation. So what we're trying to really find is this. So that tells us we need to have the normal force. Now, right now as it stands, we don't have the normal force, but we have enough information to figure it out. Up here in our F net in the y direction equation, it says the force of gravity plus the normal force equals 0. That's helpful information, because if they equal 0, that tells us that these forces are equal and opposite. They're balanced because their net force is 0. So if I can find the force of gravity, I know that I can also find the normal force. And here, if it's helpful, if you want the math to show that, here's what you could say. We know force of gravity plus normal force equals 0. So if we subtract out the normal on both sides, we have force of gravity is equal and opposite the normal force. So one more thing that we know acceleration due to gravity is negative 9.8 meters per second squared. And we know the equation for force of gravity is mass times acceleration due to gravity. So mass is going to be, we have it over here in the problem, 5 kilograms. Acceleration due to gravity is negative 9.8 meters per second squared. Oops, my square's not showing up. Okay, so take a minute and figure out what that's going to be. You should be getting negative 49 newtons. So the force of gravity is negative 49 newtons, which means the normal force is positive 49 newtons. Now, in this problem, if we're going to use F sub k equals mu sub k times the normal force, we're going to have to divide out the normal force to figure out what the coefficient of friction is, right? So if we do that, we divide out the normal force, do that on both sides, we get mu sub k equals force of kinetic friction divided by the normal force. So let's take that equation and let's bring it over here and let's plug in our numbers. Force of kinetic friction is negative 10 newtons, or let's go ahead and just use the magnitude. It's going to be the 10 newtons. The normal force is going to be 49 newtons. So if we take that and do the math, we're supposed to be getting the coefficient of kinetic friction. So you're going to take 10 and divide it by 49, and what you should be seeing is that your newtons are going to cancel, which is good, and it's going to leave you with 0.20 is mu sub k. That tells us our coefficient of kinetic friction is 0.20. And I know a lot of you are probably saying, wait a minute, that's not sig figs. I don't disagree. This particular problem should have been set up so that you could get decent sig figs, and it's not. So if you have your answer as 0.20 for your coefficient of kinetic friction, you're good to go.